We're at the point now that I'm sure a lot of you have been waiting for. The ability to play a game across a network, one phone or iPad against another. I'm going to break this up into two videos. In the first one, we'll set up our service class and get things all organized so that in the final video, we can finish the game by implementing the code that will allow us to broadcast our availability to play, invite others or accept an invitation from someone else, and then transfer our moves and actions across the network. But first, let's create a new branch, and we'll call it MultiPeer Connectivity Service. The MultiPeer Connectivity Framework supports the discovery of services provided by nearby devices and supports communicating with those services through message-based data, streaming data, and resources such as files. In iOS, the framework uses infrastructure Wi-Fi networks, peer-to-peer Wi-Fi, and Bluetooth personal area networks for the underlying transport. Apps that use the local area network must provide a usage string in their info pList with the key NS-localized string description. Apps that use Bonjour must also declare the services they browse using the NS Bonjour service key. Let's start by setting up our info pList. And first, let's set the Bonjour services. Drop down the disclosure triangle, and for the string item, let's add an underscore X and O, where X and O are both capitals, period, underscore TCP, for TCP transport. Then we'll add another item and repeat that, but instead of TCP, we're going to use UDP. Now that string, capital X, capital A, ND, capital O, is really important. So copy it to your clipboard because we're going to be using it shortly. Now if you go to the project and back again, you'll see that it has added that key to the pList. Now let's add the privacy local network usage description. And then for the string, you can add something like, would like to play X's and O's. We now need to do some coding. And I want to keep everything related to MultiPeer Connectivity Framework together, so I'm going to create a new group, and I'm going to call it MultiPeer Connectivity. I'm going to move it down below the game screen group. Inside there, I'm going to create a new file that I'll call MPConnectionManager. Now, this is going to be a service class that I will inject into the environment, so all of the properties and functions can be accessed from any view that needs it. First, we change the import to MultiPeer Connectivity. Next, we need a string that's an identifier for the service. And there are lots of ways in which one can create a constant for a string value. What I'm going to do is to create a string extension, and inside the extension, create a static var called service name. And this string must match the string used in the Bonjour services pList entry that we copied to our clipboard. And that was that X and O. Now we can create a MPConnectionManager class. Now, if I bring up the documentation on MultiPeer Connectivity, we see that it's an Objective-C framework and it's been around for a while. There are some requirements, and the one marked as important is that we have already done by adding those two items to our info.pList. The documentation goes through the process of letting you know what properties and functions are required to make this work. So we'll need to create this service that we can call from our views to initiate the advertising and browsing for availability, and then making an invitation and, when accepted, send off our game moves. So within the file now, we'll create that class and we'll call it MPConnectionManager. And because it's an Objective-C framework, we'll need to conform to NSObject, but we'll also want to add published properties that we can observe changes on so we can update our UI. So we'll also conform it to the Observable Object Protocol. Now we'll need several properties. First is one that will identify the service by creating a constant called service type, and it must be a string value. So we can use our extension on string and use our service name. An MC session object enables and manages communication amongst all peers in a multi-peer connectivity session. But my peer ID is of type MCPeerID, and this object represents a peer in a multi-peer session, i.e. the game player. And this is the one that's going to represent me, so that I can broadcast my availability. And every phone will emit a unique MCPeerID. Now we'll need an instance of the MC Nearby Service Advertiser class, and this publishes an advertisement for our services, and it'll have a number of delegate functions that we'll be able to use. Similarly, we'll need an object that's going to represent the MC Nearby Service Browser class, which allows us to search for others who are advertising their availability. And this also has a number of delegate functions that we'll use. Now we have a number of uninitialized properties now, and since it's a class, we'll need to create an initializer. When we create it as a state object using this class, it will call the initializer to initialize each of these properties. Well, the MyPeerID property is an MCPeerID object that represents the instance of our app running on our local device. And the MultipeerConnectivity Framework is responsible for creating that PeerID object that represents our devices. So to create a new PeerID for the local app and associate a display name with that ID, we'll use the MCPeerID initializer that's going to require a display name. And this is where I ran into the problem that caused me to refactor in that last video. I was going to use the user-assigned device name for this, but as I mentioned in the last video, this won't work anymore since in iOS 16, it only offers a generic device name, not the user-assigned device name. So for this initializer, we can provide your name as a string as a parameter, so that when the service object gets initialized, we're going to assign it to MyPeerID. And then an MCPeerID object will use that as the display name. The session is an MC session object, and it requires a peer, which is a MCPeerID. Well, we have that now, so we can use it. The Nearby Service Advertiser is an instance of the MC Nearby Service Advertiser. It requires a peer, which is our MyPeerID, and possibly some extra discovery info that we'll not be using here, so we'll just put in nil. And a service type, which is what we have, service type. The Nearby Service Browser is an instance of the MC Nearby Service Browser that requires a MCPeerID, which is MyPeerID, and the same service type, service type. We'll need to start advertising our availability. And at the same time, we'll want to browse for others willing to play. But as soon as we start playing a game, we'll want to stop advertising and browsing. So let's create 4 simple functions that we can use. We'll create 2 that will allow us to advertise or stop advertising availability to play a shared game. And also 2 for the same thing, but for starting and stopping browsing. To start advertising, we can call the Nearby Service Advertiser class's Start Advertising Peer function. Stop advertising calls the Stop Advertising Peer function. And there are 2 very similar functions for our 2 browsing functions. Now, before I forget, if our class gets deinitialized, we'll want to stop all browsing and advertising for our availability. So we'll create a deinit, and we'll call the stop advertising and stop browsing functions in our deinit. Next, I want to create a Boolean property called is available to play, that will initially be false. But if we changed our property in our UI, we can either start or stop advertising our availability. So we'll just use a didSet property observer here that will just call those functions. So if is available to play is set to true, we'll start advertising, else we'll stop advertising. We need to implement a number of delegate functions, and we'll need to allow our connection manager to perform those functions on our behalf. In order to find others to play with, we'll need to conform our MPConnectionManager to the MC Nearby Service Browser Delegate protocol. So to keep our code manageable, let me create an extension to our MPConnectionManager that conforms to that protocol. Let me allow Xcode to generate the stubs, and it creates two functions for us. If we find a peer, we'll want to be able to update a list that we can pick from. So as more peers become available, we can update that list and present it to our user. We'll not be receiving any other discoverable information, so we can ignore the optional dictionary. So let's create a publish property that we can observe, and we'll call it available peers, and I'm going to initialize it as an empty array of MC peer ID that we receive. So in the first function then, if we find a peer, we can append this to our array that will update our UI. Since the browsing is happening on a background thread, we'll need to make sure we bring ourselves back to our main queue. And in order to make sure that this is a unique array, we will only do that if the existing array of available peers does not already contain that one. Now, when one of those advertising stops advertising availability, we'll get notified in the second function. So we'll need to remove that peer ID from our array. Again, that has to be on the main queue. So first, we'll determine the index that corresponds to the peer ID that we receive, because it may not exist. And if it does, we'll remove that index. And then, while we're at it, when we stop looking for others, which will be when we make a connection, we should remove all from the array in the stop browsing function. That takes care of the MC Nearby Service Browser Delegate function, but we'll need to do the same now for the MC Nearby Service Advertiser Delegate functions. So we'll create another extension for that. Again, we'll let Xcode generate the stubs, and this time there's only a single function. Now, if you're advertising and you receive an invitation from someone and you accept, you can start playing the game. When you accept the invitation, you're given an invitation handler. That's an escape enclosure that will provide you with the session that you can use in your application. And you'll also want to know who you are playing against, which is the peer ID. In some cases, that user may also be sending along some data with their name, for example. Well, I'm not going to be doing that here, but it's possible. So let's create 3 new published properties that we can assign those values we receive to. First, a Boolean property that's going to, in the future, trigger an alert in our UI. So we could call that received invite, and it'll be initialized as a false value first. For the next 2 properties, we'll want to make them optional until we receive an invitation. That way we won't have to provide an initializer. We'll create one called received invite from, which will be our optional MC peer ID. So it's nil to begin with. And also we'll create an invitation handler, which is a closure that has to have the same signature as the one that we're going to get. So we can just copy that and use it. And if we surround it in parentheses, we can make it optional. Let's go back to the function then and update those properties by assigning the values that came in. But again, we'll need to be back on the main queue. The received invite will be true, so we need to access that value by using self. The received invite from will be the peer ID, and the invitation handler will be the invitation handler that we receive. And the final delegate extension will be the MC session delegate function. So let's create that, and I'll let Xcode generate the stubs. And I have to do this 5 times before Xcode stops complaining. So there are 5 functions, but really only 2 of them need any body entered into them for our purposes. I'm going to create one more Boolean published property, and I'm going to call it paired. That's false initially, so that we can keep track of when we are paired and playing a game with another device. And that will allow us to update our UI accordingly. So in the didChange function, we'll get an MC session state property that we'll be able to use to update our published properties. So let's switch on that state. I'm really only interested in what happens if I'm connected or if I'm disconnected or not connected. So if the state is not connected, within a dispatch queue main.async block, we can set the paired property to false and then change our isAvailable2Play property to true. This code block will be used for connected, but in a reverse order. So let's copy it and use it where paired will be true and our availability to play will be false. And then I can use default for any other case now and in the future. And we can use the same code as the not connected. In the didReceive function, we'll receive data from our peer that we have to respond to. And this will be their next move, or perhaps they're starting or ending a game or resetting a game. So before we can receive data, we need to know what we can send. So we'll need to create a send function within our manager class that will allow us to send that move information on to the peered player over the network. So before we do that then, all these delegate classes need a representative to perform all the functions. And that will be our manager class itself. So within the initializer, first we'll call super.init. And then we can set the delegate of all of our delegate properties to self. The session.delegate self, nearby service advertiser delegate will be self, and the nearby service browser.delegate will be self. So let's create that send function so that we'll know what to expect when we receive it. So let's think about that for a minute. When you make a move, start a game, end a game, or create a new game, our app already knows how to handle that. But what we'll need to do is to send over our connection enough information so that we can replicate that move on their device. And this is all done by sending data between 2 devices with information that it can decode and respond to. Well, that word decode and respond is a clue. We want to encode our data on our end so that we can send it over and be decoded on the other end. So first, let's think of the different actions that one can perform that will require some action on the receiving end. Well, when one of our users taps on a button to indicate that they want to go first, that information needs to be sent. When we start playing, we need to be able to send along the square index and who it is that's tapping there. And then if we decide to end a game, well, that's another option. And if we want to start a new game, we'll need to be able to notify the peer of that information as well. So in addition to that action type, we'll want to pass along the ID of the person who's playing, along with, if it's a game move, the index of the square that's being played. So let's create a new file called MPGameMove within our folder group. And this will be a struct that will represent that information. And so we'll call that MPGameMove and make sure that it conforms to the Codeable protocol. Then I can create an enum called action that'll be of type integer, and it will be codable. And this will represent those 4 possible actions that we just talked about. So those cases will be start, move, reset, and end. Next, we can create 3 properties that we can encode to data and send. One will be the action. The second will be an optional string for the player name. And then the third will be the index for the move being made if it's a move, so it will be an optional int. To help with the coding, we'll create a new function called data that returns an optional data object. And then for the return, we can try to use a JSON encoder to encode the object itself. Now we can return to our manager class and create a new send function that will receive a game move and send it on using the current session's send method with the encoded data. We'll need to make sure that there are some connected peers. And in our case, there's always only going to be one, but for a multiple player game, there could be many. Then within a doCatch block, we can check to see if we have data from the GameMove data object, and then try to send it to the connected peers using the reliable option. If it fails, we can catch and print an error. Finally, now that we know what we're sending, we can return to our didReceive delegate function and deal with what it may receive. So we can check to see if the game move data is valid first, using an optional try to JSON decode that data into an MPGameMove object type. Then, since we're going to be updating on the main queue, we can embed it in another dispatchQueue.main.async block. Then we can switch on the GameMove's action and respond accordingly. So you'll recall we have 4 action cases, so let's add them. One for start, one for move, one for reset, and one for end. Now we find ourselves in a bit of a predicament because we need access to our game service now from within this new class. This is in the environment, but we can't use an environment object here in the same way that we do in a view. However, there's nothing stopping us from passing it in somehow as a function argument. Let's create an optional property called game that is of type gameService. Then I can create a setup function that will receive a game service from our view and assign it to that property. So if we set that function up before we make any function calls, that required game function will be okay. Back to the receive function then. Here's where we'll be needing those game functions. First, the easier two, reset. If we receive a reset action, we'll want to issue the call to the game's reset function so that it will clear the board and allow us to play again. For end, if we receive an end action, we'll need to disconnect from the current session and then indicate that we're available to play again. And you'll recall that we've set up a didSet on this so that we know it will now start advertising our availability again. When we receive a move action, the index for the square to set that player. It's optional, however, so we can unwrap it and then call the game's makeMove function at that index. For start though, I don't quite have enough information yet to create this case, so I'm going to have to add a break statement here and call it a day for this video. When we receive a start action, we'll also receive the player name, and we can use that information to compare it to the names that will be provided during the setup. We don't need to do anything with the remaining functions because we're not passing any resources or input stream, so we can just leave those function bodies empty. In the final video of this series, we'll create the remaining view that will allow us to see who is advertising and be able to select one to invite to play. Or we'll be able to accept an invitation if someone else has invited us. And we'll make sure that we send our moves across the wire. We'll also then be able to complete this case here. Before I do that, however, let's make sure that we commit what we've done so far to our Git repository.